And since I just realized that my camera was off, I'm just going to quickly review this. I'm so sorry. So we were given f prime, we're given a condition, we found the antiderivative, the most general antiderivative. I simplified it a little bit, and then I plugged in the point. When the function is -6, x is 1, and I got this equation, and I solved for c, -61/10, and I went back to plug it in. Sorry, it was off just for a minute. I just forgot to turn it on again. Any questions on this problem? See if we want to work on another. If not, we'll move on to the next set.
Can we do 25?
Yes, of course. Which page am I on? I'm on page 6. Very good. 25. Very good. So again, 25 is exactly like these, but that's fine. So dB over dt equals 0.03 b, and we are given that b of 0 equals 500. Perfect. It's not exactly the same. I'm glad you picked it, because this here we were not given a condition. Here we were just on our own. In other words, we were determining the most general function, antiderivative. But here we are given a specific condition, so I'm glad that you picked that. Okay, perfect. Again, the same idea. So I have dB equals 0.03 b times dt. We're multiplying both sides by dt. We are dividing both sides by b. 0.03 dt. We're integrating both sides. Like before, we get natural log of the absolute value of b equals 0.03 t plus a constant c. So far, so good. This is the third identical example. But at this point, we are told when x is 0, the function is 500. But I haven't solved for the function yet. So I have b, the absolute value of b, equals e to this, e to c times e to 0.03 t. Okay. Now I'm told that b is 500 when t is 0. b is 500 when t is 0. Okay, perfect. So now I will find the constant. Maybe in this situation I should not separate it, or it is the same thing, but you don't have to separate it till you find the constant, or you can present it as I did. Okay, so the absolute value of 500 is 500 equals, when t is 0, e to 0 is 1. So I have e to a constant c. How do I find the constant? I apply natural log to both sides to bring c down. So then c equals natural log of 500. So then I have the absolute value of b. I'm just going to copy this here one more time. So the absolute value of b equals e to the constant, e to natural log of 500, multiplied by e to 0.03 t. Now, there is another rule that we discussed some time ago. A base raised to log of the same base of x is x, which means that this is 500. Base e, and here the log has also base e. So e raised to natural log 500 is simply 500. The next step, like before, with the other two examples, or three examples, I have to write the absolute value of b. That's an equation in which I have to change b into plus or minus 500 e to 0.03 t. Not so fast. What do I mean by that? I put plus or minus because I had to, because of the absolute values we just discussed. However, I am given this condition, and I have to make sure that I select the correct symbol based on the given condition. So if I plug in 0, I have to get 500, not negative 500. So let's see which one works. If I plug in 0, this is 1. I cannot get plus or minus 500 because I'm specifically told b of 0 is 500. So I will say only plus, because the minus will not give us this answer. So in the past, here we had plus or minus because there was nothing specified, no indication whether I have to use plus or minus. But now I am given an initial condition. And if I choose plus or minus, this will contradict the situation. So when I plug in 0, I have to get positive 500, not negative 500. So therefore, there is only one solution. B equals 500 e to 0.03 t. The initial condition helped us make a decision which of these two symbols is the appropriate one. Because this was not the general case. Good, very good example. Thank you. Do we need anything else from here, or can we move on? We have plenty more on the next page, I'm sure. Okay, here they are. And then we have 2 more sets, and then we can look at word problems. Do you think we got the idea? These are all the same with what we just did, with the one with B. Solving by separating the variables. Okay, so let's practice 31 through 38. Pretty similar, but they look a little bit different, so let's work on those. 31 through 38.
Can we try 34?
Yes, please. 34. So 3y squared dy over dx equals 8x. Very good pick, thank you. Good. We have to separate the variables. Of course, first thing that I have to do is multiply by dx. So 3y squared dy equals 8x dx. Are they separated? Yes, they are. Y alone on one side, x alone on the other. So now we are ready. We're applying the same operation to both sides. We're integrating. Okay. So this, the left-hand side is 3y cubed over 3. And notice I forgot to mention, let me mention from the beginning, we only use one constant. So you can say, wait a minute, you wrote this, but where is your constant? You have the constant here, but you don't have the constant here. We don't use two constants. This constant plus this constant is together C, condensed in C. So we don't have to put a constant here and another constant here. We only use one. Okay, so I'm not going to put a constant here. I'm just going to put it to the right. So equals 8x squared over 2 plus a constant C. Of course, I'll simplify. I have y to the third equals 4x squared plus a constant C. How and what procedure we apply to both sides to get y? We are solving for y. Y is the function we need. What should we do to both sides to solve for y? And this is from algebra. This is nothing new. What should I do to both sides to solve for y? Anyone, please?
Would you cube each side?
The cube root. Yes, indeed, the cube root. Very good. So this we have y equals the cube root of 4x squared plus a constant c. And this is it. Any questions? Any questions? It was a very good pick, very good example. Okay. I'm going to choose one. I'm going to choose 37, and then you choose the next. Anyone, any questions on this one? Sorry, I don't know if I asked enough or waited enough. Any questions on this? Okay. Good. So let's copy 37. Dy over dx equals 7 over y squared. Okay. Good. Well, this time I'm going to have to cross multiply, meaning y squared dy equals 7 dx. Are they separated? Yes, of course. X alone on one side and y alone on the other. So we are ready. So this is y to the third over 3 equals 7x plus a constant c. I will multiply both sides by 3. And only then I'll take the cube root or apply the cube root to both sides. So then y equals the cube root of 21x plus 3c. Pretty similar with the previous one. Okay. Do we need anything else from this set of 31 through 38? Yes, let's also look at 31. In 31, we have dy over dx equals 5x to the fourth y. Okay. Can anyone walk me through now, since you've seen so many? What would you do first? What is the first step?
Multiply dx.
Yes, multiply both sides by dx. Thank you very much. 5x to the fourth y dx. Perfect. Are they separated? The answer is no. Because on this side, I should have only only x, nothing else. But I do have y. So what should I do now to both sides?
Divide by y.
Yes, very good. Thank you very much. dy over y equals 5x to the fourth dx. Now we are in business, meaning y is alone on one side, x alone on the other. And now we are ready to apply the same procedure to both sides. Good. Now this side we already know is natural log of the absolute value of y. The other side is 5x to the fifth over 5 plus a constant c. These two go away. Again, I have to convert. E to this equals that. So the absolute value of y is e to x to the fifth times e to the c power, and you know y. And I will change this into c1. So then the absolute value of y equals c1 e to x to the fifth. So now I only have to write plus or minus C1 e to x to the 5th. I don't have to worry about plus which one because I'm not given a condition. I don't have C. Anything can happen. So this is basically the fourth example that is very similar to the, I mean, they're all very similar. Okay, the last set, however, is this. So let's work on this before we look at more problems. 39, 40, 41, 42. Okay, I'll start with 39 then. So we have y prime equals 3x plus xy. And they're telling us that y equals 5 when x is 0. So this is very clear. There will be no ambiguities. We'll know exactly what is going on. Okay. Can anyone suggest something? Because we need to make a change in this equation. What should the change be? What do you think? There is something that I have to change. What do you think that would be? If you look at all these previous examples. What do you think we need to change? Anyone? Well, I need to change
Right in
the
standard form?
I need to change this. I need to change it into dy over dx. I need to multiply both sides by dx. Careful. And then I realized that these variables are not separated. I cannot integrate. So I have to see something here. Is there anything I can factor out here? Is there anything I can factor out?
An x.
Yes. So I have dy equals x, and in parentheses I have 3 plus y dx. X should be there. It's in the right spot. Dx is in the right spot, but this one is not. It does not belong there. What should I do? What should I do to both sides to get rid of this? It doesn't belong on the right-hand side. What should I do? To both sides, of course. To get rid of y plus 3. Which operation?
Would you subtract it?
I can't because it's multiplied.
Divide it?
Exactly. dy over y plus 3 equals x dx. This is the only way. Very good. Now I'm ready. How come? Yes, x alone on one side, all y's are on the other side. So I can integrate. The right-hand side is easy because it's x squared over 2 plus a constant c. I cannot forget that x is 0 when y is 5, and this will help us with c. However, I have to be careful with the left-hand side. So I'll take it on the side. I have dy over y plus 3. Let u be What is our substitution here? Anyone? What substitution do we use here?
Y plus 3.
Of course. Luckily, du equals dy. So this is the integral from du over u, which I know is natural log of the absolute value of u plus a constant c. And then I have to go back and replace it. You could ask, and I'm sure some of you are thinking, what are you doing all this for y plus 3? Because obviously the derivative is 1, la la la. You don't really need to do this. Correct. I would agree with you. However, if it happens that you have a 2 in here and you don't do all this, you may miss the constant. So I highly recommend always stick with the rule. Use the substitution and then go back and plug it in instead of rushing through, because a constant can throw off the whole answer. Okay, good. So then I know the answer on the left. The answer on the left here is natural log of the absolute value of y plus 3. Okay, so this was a side calculation. Okay, so now this is back where we were 20 minutes ago. E to this power equals this. So the absolute value of y plus 3 equals e to the constant times e to x squared over 2. Okay, now I need to find the constant. I can find the constant in this step, or I can find the constant in this step. It doesn't matter. So when x is 0, this piece is 1. This piece is e to c. And y is 5. But 5 plus 3 is 8. The absolute value of 8 is 8. So apply natural log to both sides. So then the constant is natural log 8. If you do it here, it's the same thing. When x is 0 and y plus 3 is 5, 5 plus 3 is 8, natural log 8. Same thing. If you determine the constant in this stage or you determine the constant in this stage, it's the same thing. Still, when I plug it in, I will have just 8 in front. So then the absolute value of y plus 3 equals 8 e to x squared over 2, or y plus 8 equals plus or minus 8 e to x squared over 2. Not so fast. Why? I have the initial condition that must work, and it will not work with plus or minus. So when x is 0, y is 5. So when x is 0, y is 5. When x is 0, this is 1. The right-hand side is plus or minus 8. And when y is 5, 5 plus 3 is 8. No. I can only choose the plus. So then finally, only y equals negative 3 plus 8 e to x squared over 2. So in the previous example, or several of the previous examples, we were not given the condition. So we didn't have C. But now when I have C, the final solution has to work with the initial condition. And the negative sign in this case does not work. Because when x is 0, the left-hand side is 8, not plus or minus 8. So I can only choose the positive, and then I have to move 3 to the other side.